centrioles, and the chromosome is kind of spread out, right? That's interphase. Now, when you get to prophase, early prophase, the nuclear envelope starts to disappear. The centrioles, the pairs of centrioles are moving to opposite ends of the cell, and these chromosomes start to condense. And you can see that better here in late prophase. You can see the fibers, right? And the chromosomes starting to condense. In metaphase, they're lined up in the middle of the cell. So they showed you this way. So you see all the spindle fibers lined up, all the chromosomes lined up. This is sister chromatid. These are sister chromatids. This is metaphase, lined up right in the middle. And then in anaphase, they have early and late, but I don't really care about that as long as you have the right phase. The sister chromatids are being pulled apart. By the end of anaphase, both sister chromatids are opposite ends of the cell. And everyone see that. Right? These are going to this end, this is going to this end. Telophase. Telophase, 2 nuclei. T for 2. You now have 2 complete intact nuclei. So when you remember your phases of mitosis, you have to remember here you're preparing, so you're getting rid of the nuclear envelope, you're making your spindle fibers. This is the longest one, right? And your chromosomes are condensed. In metaphase, this means middle. Middle. You're lined up in the middle. Anaphase is for apart. You're cutting apart. Remember anatomy, to cut up, right? Up. You're cutting the sister chromatids. You're pulling them apart. And then telophase, you remember now you have 2 new nuclei. And the cell cycle, of course, includes interphase. So there's a mnemonic if you want to know the cell cycle in order. I passed my anatomy test.
There you go.
And this part, though, of course, is my turn. Okay. And remember that interphase has G1, S, and G2. Okay. And then, of course, cytokinesis. Now you have 2 identical cells, and they're intact. They each have their cell membrane, they have their nucleus, and they have the same amount of chromosomes. Okay? So if I were to put this up on the test for a question, what would I blank out?
On the right side?
Yeah. I would say question number 3, for instance. What is this? And you would say cytokinesis. I blank everything out, and you, of course, have to know the labels. Again, for the abdominal regions, oh, shoot, where is it? Oh, I forgot it. Oh, I'll put up a slide for it. It has, remember that one slide that had the 9 regions?
Yeah.
You need to know the regions and an organ beneath that region, okay? Not this one. This one only, oh yeah, this is the 9 regions. They don't have the names. They have the organs. This is your cell. Know it, love it. It's labeled. There's the numbers. Okay. This is the skin from your book. I just want to show you the kind of a better picture than this. That's though what you're going to be tested on. Has all these numbers. This is the key. You can make this bigger. It's kind of small. And believe it or not, most students do well on this test. Why? Because I gave you everything you need to know in one PowerPoint.
Awesome.
Believe it or not. Remember directional terms and planes of section. Like I could say, and I won't use any layman's term. I can say my brachial region is blank to my digits, my phalanges. Now the histology part. This is the hard part. This is the part that Nan made individual slide cards. And you just shuffle them, throw them out. It's like playing cards, and you know the answer like that, right? Is it Jeopardy where you do that? Or one of those where you know the answer. All of these slides are showing you, these are individual slides, showing you histology slides, showing you simple squamous epithelium. I know it doesn't mean anything to you right now. It will when we do the chapter. Diffusion can occur through here. This is one layer thick. Simple means it's one layer. Squamous means the cells are squashed. They're flat. And they usually have a nucleus right in the middle. And epithelium because it's an epithelial tissue. Okay? Simple squamous epithelium. If I put up a slide, if I put this slide up, for instance, you would have to write on your question number, let's say this is 5, you would write simple squamous epithelium. You write epithelium, you got it wrong. You write simple, you got it wrong. You write squamous, you got it wrong. You have to write the complete name, the complete tissue name. This is simple cuboidal, and it's called cuboidal. Epithelium is named for the type of cells, the structure that looks like. And they look like little ice cubes. All of these though. Simple columnar, they're columns. Simple means one layer. Stratified means you got a bunch of layers. This is stratified squamous epithelium. This is pseudostratified, ciliated, columnar epithelium. That's just confusing. What happened to my
What? So, all those pictures are the same thing, just she's gonna give you more of those
there was one
pictures.
slide that was missing, I thought, right? I don't know why it keeps hiding this. You know? This is keratinized stratified squamous epithelium. The reason it's different, and you'll see how much thicker it looks and the darker the print looks, is dilux, is because this is your skin. That's what it is. And it has a lot of keratin in it. And that makes it waterproof, right? Water doesn't get inside because your skin's intact. Pseudostratified means that it looks like there's more than one layer, but it's not. It's just squished together. They're tall columns, so you feel the nuclei squished together. And then you see the cilia, the little hair-like projection. Remember we do this? That's what that cilia is. Transitional epithelium. Certain areas, certain organs have more of a transition. Your urinary bladder. When it's empty, it's deflated. When it's full, it has to distend. So this tissue allows organs to distend and then recoil back. So that's why it's called transitional. What are these? What's this? Transition. What's this? Transitional what? Transitional epithelium.
Oh.
What's this?
Keratinized.
Stratified squamous epithelium. So the other.
So very wrong.
And this is why you cannot look at a complete, don't study like this, you'll fail the test. You have to do like Nan did and do individual slides. And then do your flash part, your dance. What is this?
The cilia one.
What is this?
The first one. Stratified.
What is this? Some of them are easy, right? But some of them are not so easy. I'm going to show you some. What is that?
Transition epithelium.
When you look at transitional epithelium, what you're going to notice is that it has folds. It has folds because it has to be able to stretch. I'm going to take you back to sewing. When you get a big piece of material, yards of material, you have to make pleats. You know what pleats are? That big yard of material all of a sudden comes like this, because you have these folds. Increases surface area, right? Now you can just stand and then go back forward. This is called, now we pass epithelium. Make sure you make the difference in your head. When you do that card test, when you do the card, playing the cards, write out the name, or you're going to get it wrong. One thing that people do for some reason is they put connective tissue at the end of everything. They get it wrong. This is called a roll-art connective tissue. It is a type of loose connective tissue. We're not going to talk a whole lot about it right now until we get to the tissue. But one thing is it has a lot of these pink collagen fibers. Thick pink bands are collagen fibers. The thin bands are called elastic fibers. The black. This is dense, regular connective tissue. It's regular because it's stacked on top of each other, right? The collagen fibers. Wherever you see pink, which are collagen fibers. So that's dense, regular. Adipose is a type of loose connective tissue, and the adipose is probably the easiest one to see because you have a cell with a lipid droplet in it. And so everything's pushed out, and the whole lipid droplet is, it looks like it's an empty cell. It's not. It has the fat lipid within that cell. So these are easy. What is this? Very good. Who knew that? How did you know? Some people have memory. No, but these are simple squamous. What is this? That was easy. That was that. Remember, you have to say adipose connective tissue. Can't say adipose tissue. It's a connective tissue. Later on, when we get into the units, I don't care if you do it or not. But right now, you have to say connective tissue when it's a connective tissue. You have three different types of cartilage. Cartilage is a connective tissue. This is hyaline. Hyaline means glassy. And so what you notice is that the cells are spaced apart. The chondrocytes, cartilage cells called a chondrocyte, sits in a little depression. That little depression is called the lacuna. So if I point to something like this, or this, or this, or this, any of these, it's a chondrocyte in a lacuna. That's hyaline. This is fibrous. Fibrous cartilage you find, for instance, in the menisci of your knee. In between your vertebrae. Think of this that you see in here. That's fibrous cartilage. Or that's the way you have to look at it in histology. So what are these? What is this? Dense, regular connective tissue. What is this then? Fibrous cartilage connective tissue. Both of these are, and so both of these are the dense regular. Connective tissue in the practicum, your hand's going to get tired of writing, so you just write CT. I know you know that's connective tissue. Elastic cartilage connective tissue. See, I started doing it myself. What you're going to find, remember I showed you earlier that black fiber, and I said it was the elastic fiber? You see a lot of black. That's how you're going to know you have elastic. You see a lot of black fibers. That's elastic cartilage connective tissue. Osseous connective tissue. Does anyone know what osseous connective tissue is? Bone. And it kind of looks like a tree trunk. See the tree trunk? So the tree trunk, this is one osteon, is the central canal. The cells are called osteocytes. They also sit in the depression, so that's an osteocyte in a lacuna. Here where it says B, only the osteocyte sitting in the lacuna. Where it says A, that's the central canal. Smooth muscle. We're now in muscle. We're not in connective tissue anymore. Do not put smooth muscle connective tissue. Why do I keep telling you that? People keep doing it. every cement, and I keep hammering it. Do not do it. Do not do it. And as soon as I start grading your practical, I find at least 10 people who do it. But I'm going to still say it. Don't do it. Smooth muscle is called smooth. It is muscle. This is smooth muscle tissue. It is muscle, but there's no striations. You don't see any of these lines going across. So you know that's smooth muscle tissue. This is skeletal muscle. This is the steaks that you see. You see a lot of striations. Striations. It's multinucleated. That one's not good word. You can see the different multinucleated. Cardiac muscle. How you differentiate between cardiac muscle and skeletal muscle is that it's branched. So here you get this branching, right? And you get these big lines. Those are called intercalated discs. Here you can see the branching. Here, this one's better, like you can see the intercalated disc. Here you can definitely see the branching. And this is nervous tissue, and these are called giant multipolar neurons. And the reason they're called that is because they have a lot of processes extending from them. Multipolar neurons have a lot of dendrites extending from them, but only one axon. So here you can see, this one's better. There's the one axon. This is the cell body, also known as the soma, and all these are dendrites coming off the cell body. Or soma. That's it. That's your practical.